The aim of this video is to show you how to detail your slab. So this right here, we have a structure that we've paneled. You have panel 1 here with depth of 150 mm. 150 mm depth is the minimum depth for your slab. The minimum slab thickness is 150 mm. So I want to detail this, a fully detailed drawing for that other structure I just showed you. So here is fully detailed. You have your bottom member, which is this, and these are the slab details, the detail of that particular reinforcement. 20 y 12 bar mark 4 at 250 mm center to center B1. So this is what we want to achieve. We want to detail panel 1. I want to show you how to detail your detailing. This is your distribution bar details, having 10 y 12 bar mark 1 at 250 mm center to center B2, B1 for your bottom member, B2 for your bottom distribution bar, T1 for your top members. So let's go back to this panel. So I'll just copy the distribution bar and brought it here. Instead of taking a line, you can easily just create a line for yourself and stuff. If you're starting if you're doing it yourself, you just create a line. Ordinarily, before you start detailing, you would have done your design. Do your design in Proto Structure or Orion. Better I use Protado. So when you export your design drawing to AutoCAD from the raw file, then you can now start doing your detailing. Away from that, you can manually just do your slab detailing in AutoCAD here. So if you are doing that, you are putting your reinforcement with a thickness of 0.30 mm. So this is a reinforcement are running through a distance. They are running through distances, and we are using spacing of 250 mm spacing. 250 mm is the maximum spacing between two reinforcements on your slab. It could go below 250. You could have the spacing at 200 millimeter. You can have it at 175 or at 225, but it's at even at 150, but it should not go above 250 mm to avoid deflection. So therefore we come back here. So I'm just going to do copy part of this detailed work and take it up there to detail that panel 1 to save us time. So looking at this closely, you see this is our reinforcement, and you see this circle. This circle tells us the point we are trying to detail, that this is the reinforcement I'm trying to detail. Then you will now see the other line showing those arrows. The arrows is showing you that this particular reinforcement is spanning from this point to this point in this panel, and then you now follow through the line going across them that will lead you to the actual detail of that reinforcement, which right here you see 20 y 12 with bar mark 4 at 250 millimeter center to center. So I am going to copy this for the distribution bar I've taken up there. I've copied up there. I'll just copy this and take it up there and place it. So which same thing will have to be done for the other side. For your bottom member, you also draw your line and bring out your details, put in your circle at the reinforcement you are trying to detail. So I'm just going to copy this, take it up as you see the way it is. If you're constant with AutoCAD, you will know that when copying anything, the point where you pick it from and where you drop it is very important to avoid ambiguity, to ensure what you're doing goes accurately the way you want. So I pick it at the same point and drop it at the same point on the other one with panels. So I have this. So that will be running through this span. So these are distribution bars running through this span. So to get the actual number of reinforcement that will run through that span, what you just have to do will have to be you divide, you get the distance, divide it by your spacing, and that will give you the actual number of reinforcements that will be running through your span. Okay, you have 2489 divided by 250. That's 2489 divided by 250. So it give you 9.9 or something, which will be approximately 10 by 12. So to make this more explicit, you could add this 10 by 12 by Mark 1 at 250 millimeter center to center. So I say C slash C, telling you that it is center to center reinforcement spacing for the panel. Thereafter, I could also put at 250 millimeter to just give more explicitity to this detail. So I'll put at, yes, so you have 10 y 12 by Mark 1 at 250 millimeter C slash C B2 for the longer reinforcement, right? Running through the shorter span. So now I will now go and pick up the bottom member and also do the same thing. Delete your panel, your paneling, your your the panel you are detailing has to be clear. So remove that panel details. So I'm going to also pick the details for the bottom member. I'll take it up and also do the same thing I just did. So that's how it goes. In case for you to be able to do this, you should know how to use your AutoCAD though. So if you don't know how to use your AutoCAD, you don't know how to draw your line, you don't know how to copy, you don't know how to paste, you don't know how to set your dimension style, then you have to watch my previous videos in YouTube. You go to Chukuma Victor, check Chukuma, the channel Chukuma Victor. You're able to see, go through, you see we have done videos on how to use your AutoCAD to copy, to move, to paste, to trim and all. Or you can check me on Facebook, Uchevix Act. So we've brought our reinforcements. It's also spanning through a distance. So you do your division and get that. So continuing, apart from your bottom main bar and bottom distribution bar, you have your top bars at continuous edges and at discontinuous edges. So if you look at this panel very well, you see that your at your left hand side is a discontinuous beam, um, edge, discontinuous edge. At the top side, you have your discontinuous edge, but at your right and your bottom, you have a continuous edge, meaning that on this side that are continuous, you have another panel by that side. The side that are discontinuous, you don't have panel there. So for this, for my left hand side right here now, you see we have our top bar. That's where you have your return bar. Your return bar, the return takes a distance. I believe you should know the from your BS code. You should get the distance to which the return is supposed to span. So use that calculation and get the actual length. So you will also detail the for the continuous edges. We have your bar running through across the two panels like this. Now is touching this side of the above panel and the bottom panel, so that is the top bar to take care of the moments at those continuous edges, right? So at our left right hand side is also continuous, so we also have our top bar running across both panels. So if that is done, you will see that you now have your bottom main bar, bottom distribution bar, and top main bars for both your continuous and discontinuous edges. So you are also to ensure you detail each and every one of them, showing us the number of the number the reinforcement is going is the spacing is going through, and also your reinforcement diameter, which is y12 for slabs, and your spacing 250 millimeter center to center. You also remember to put your top bars T1 or T2, for bottom bars B1, B2, for bottom member B1, bottom distribution bar B2. So I'm just going to copy this and bring it here for me to detail this top bar. Then I will move this. Now I'm using move. I'll just click on it, move it to this point. Now telling you that this is the actual reinforcement I am trying to detail. So now coming up, I'll just pick my test instead of copying. So that you see how you pick your test, you type in your words that you actually want to put. You have that's also spanning through the same distance with your bottom distribution bar. So that will be 10 y12 bar mark, whatever, let's bar mark 2 or bar mark 3 at 250 millimeter center to center T1 as a top bar. So for a slab, a typical slab, we are going to be having a T1 only. We are showing our top distribution bar. If I put in your top distribution bar, it's still going to take through for this. Now the top distribution bar will still take the same dimension as the bottom main bar, so that it will take care of the top distribution. We get. So for me to rotate this, I go to quick version, click on it, and then I'll just change the rotation and then align it very properly. Ensure your dimension line does not obstruct your detailing. So this is for this top top member. I also do the same thing for top distribution bars. For other top bars running through the continuous side and the one of this continuous side. So with this, you'll be able to do your slab detailing, showing all aspects of your slab. So just changing it to align with what I have on the panel, on the detailed one, completely detailed one. So with this now, you should just continue and put in the details for your um top bars like this. For this now, put the details for it, put the details for this other top bar, and with this you'll be able to do your slab detailing effectively. If you have any question, just write on the comment section, or you could just send me a message. Just type your question and I'll make video to answer your question and clear any ambiguity to ensure you are able to understand appropriately. Thank you.